Very good afternoon to all. Okay, so I welcome you all for this 8th lecture of our subject Industrial Hydraulics and Pneumatic. In today's morning lecture, we have seen the applications of the fluid power. Okay, that means the applications of the hydraulics. Okay, and pneumatic also. Okay, now we are going to see the first component of hydraulic system. Okay, and as per the syllabus, the first component is the hydraulic actuator. Okay, so we are going to see the basic about the what is mean by actuator. Okay, it's a classification, and then one by one in detail we are going to see the its working principle, construction, everything we are going to see them. Okay, now before going to the actuator, we should know the basic elements of fluid power system. Okay, fluid power system is both your hydraulic power system or pneumatic power system. Getting it? Whose sound is correct? Let me check. Okay, so as we know that our fluid power system, it consists of the mainly four elements. Now the question arises is that which are that four elements? So the first is the energy conversion elements. Energy conversion elements. Now which are that first energy conversion element? The answer is your pump and your compressor. Okay, your pump and your compressor are the energy conversion elements. Okay, now what is the role of the compressor or the what is the role of the hydraulic pump? Okay, if I'm telling the if I will tell the if I will take name of the pump, that means I'm talking about the hydraulics, and if I will take the name of the compressor, that means I'm talking about the pneumatic. Getting it? So the first element is the your hydraulic pump and pneumatic compressor. Here compressor means it is used for the pneumatic system. Getting it? So the pump will convert your mechanical energy into the hydraulic energy. Okay, in many fluid power application, we need to convert the pressure energy of the liquid. Okay, pressure energy of the liquid. That means your hydraulic energy into the mechanical energy. For what purpose? To perform the work. Getting it? So this function actually the pump. What is the it converts the mechanical energy to the hydraulic energy. See, pump is the element which convert the mechanical energy to the hydraulic energy. Getting it? Same compressor. Then we need another element, that is the fluid energy storage element. Okay, fluid energy storage element. Okay. To store the energy, we need a elements. So for that purpose, a reservoir, or one more name it is given, that is a accumulator. So accumulator is the fluid energy storage element. Please remember in this point. Pump or compressor is doing the conversion of mechanical energy into the hydraulic energy. Okay, and accumulator is store the fluid energy. Then after storing, we need another element, that is the fluid energy control element. Okay, we need to control the fluid energy. So fluid energy control element. So the walls are used to control the element. Now which are the different walls that we are going to see in the unit number 2 and 5th? Okay, direction control, flow control, pressure control. Okay, walls are required to control the fluid. Okay, fluid energy control element. Okay, then the very important element is the energy conversion. Another energy conversion element, that is the accumulator. See, pump, what is doing? He is converting the mechanical energy into the hydraulic energy, fluid energy. But actuator, its a principle is opposite, or its a function is opposite to that of your pump. Okay, that of your pump means what? Accumulator is the element, actuator is the element which converts the hydraulic energy into the mechanical energy, into the mechanical energy. For what purpose? To perform the useful work. I will once again repeat. In many fluid power application, we need to convert pressure energy of liquid. Pressure energy of the liquid means it's called hydraulic energy into mechanical energy. For what purpose? To perform useful work. Okay, and this function is accomplished by the device which is known as actuators, which is known as actuator. This is the simple meaning of the actuator and the function. Conversion of pressure energy of liquid, that means the hydraulic energy, into the mechanical energy to perform the useful work. Okay, and that device or that element or that component of the fluid power system, it is known as actuators. Okay, so the actuators are the devices which are used for converting hydraulic energy into the mechanical energy. Okay, and therefore it's have the function which is opposite to the your pump, which is opposite to your pump. Getting it? So these actuators can be used to produce your linear motion, or to produce a rotary motion, or to produce a oscillation motion in a hydraulic system. Okay, what is the where to use this actuator? Okay, if this question arises, then you should give the answer like that. Actuators are the elements which are used to convert the pressure energy of the fluid, that is the hydraulic energy, into the mechanical energy to perform the useful work. And actuators can be used to produce linear motion or a rotary motion or oscillation motion, okay, in a hydraulic system. Getting it? And in this today's lecture, we are going to discuss about the principle, construction, operation, and the applications of the various hydraulic actuators. Okay, and the motors which are used employed in a hydraulic system. Okay. Now the basic here concept are, one minute. Basic question arises is that what are the actuators? Okay. Once again, I'm repeating because this basic is important. What are the actuators? So actuators are the devices which are used for converting hydraulic energy into the mechanical energy. Getting it? And again, in another words, I can say actuators perform a function just opposite to that of your pump. Actuators are performing the function just opposite to that of the pumps. Okay, so what are the pressurized hydraulic fluid which are diluted by the hydraulic pump? No, pressurized hydraulic fluid which is diluted by the hydraulic pump, that is supplied to the your actuator. Getting it? Which, and that actuator which convert the energy of the fluid into the mechanical energy. Means this mechanical energy is used to get the work done. Okay, that means input is your hydraulic energy here in case of the actuator, and output is your mechanical energy. That means that mechanical energy is used to get some work done. Getting it? So these actuators can produce your linear motion, rotary motion, auxiliary motion. Okay, please remember these three words. Okay, and these actuators normally can here just I'm giving the introduction. So these actuators can be used for lifting, tilting purpose or clamping or of opening or closing, metering, mixing, turning, swing, counterbalancing, bending, and for many other operation purpose, you can use this actuators. Okay, and special operation here I want to mention is that are the rollover devices, conveyor, wall operators, printing process, then rock drill, die, clamp, motion tool, etc. These are the special applications where actuators are used. Getting it? Okay. Now let us now here itself. Here itself, I want to clear the one thing is that these actuators. Okay, actually, it is classified. Okay, in two main types. Okay, hydraulic actuators are classified into main two types. Okay, based on the type of motion, which type of motion actuators produce. Based on that, actuators are categorized into two parts, into two groups, based on the type of motion actuators produces. Okay, so one is the linear actuator, one is the linear actuator, and as already I have given in the introduction that linear actuators also called as hydraulic cylinders. See, hydraulic actuator having the two types. One is the mic is on. Okay, hydraulic actuators having the two types. Okay, based on the type of motion produces. So one is the linear actuator. Okay, so linear actuator also called as your hydraulic cylinder. Okay, and if you get the or that actuator produces rotary motion, that time that rotary actuator also called as hydraulic motor. Hydraulic cylinder, that means actuators are producing the linear motion, and if actuators are producing rotary motion, it is also known as or also called hydraulic motors. Okay, so please remember this two category of the hydraulic actuator. Okay, so this was just a basic part. Okay, now we'll go for the in detail. So the basic definition I would given that actuators is the element or the device which convert the mechanical energy into the hydraulic energy, or you can call pressurized energy of the your fluid or liquid into the mechanical energy, and that energy is used to perform the useful work. Getting it? Now let us go for next point. Okay, so please look at this slide. I have given the another definition of the actuator. And as we know that these actuators are very important element for this fluid power system or the hydraulic system. Okay, so this is a very important and irreplaceable element of the component, or we can call part in the fluid power system. Okay, and which involves or that actuators are producing the three types of motion. Okay, one is the linear motion, then another is the rotary motion, and third one is the oscillating motion. Depend on the or based on that the motion which are produced by the actuators, it's having the two types. One is the linear actuator, it is also called your hydraulic cylinder, and the rotary actuator. Okay, it is also known as hydraulic motors. Okay, so actuators is designed to deliver a desired motion. Please remember this word. Okay, actuators are designed for what purpose? To deliver a desired motion. Now desired motion means what? Your linear motion or rotary motion or oscillating motion. Okay, and what are the motions it produces? Now depend on that, it's having the subcategories also. And again, in general, we can tell like that this actuators is a device. Actuator is a device, okay, which establishing a energy flow, okay, between your input port and your output port. Okay, at the input side you will get the your fluid energy, and output you will get the mechanical energy. Okay, so that power exchange between the your input port and the output port will be completely defined by the two conjugative variables. Okay, and that variables, it is named as a uh, yeah, different efforts like force, torque, voltage, etc. Okay, and the variable like flow, that means your velocity, angular rate, okay, then current. These are the another conjugate variable. One is the effort. Efforts means what? Force, torque, voltage. And a flow means what? Velocity, angular rate, and current. Okay, so in between your input port and output port, okay, your variables will be there. Okay, now you can see in this diagram also. Input port, here you will get the your pressure and flow. Pressure I indicated by the P, and flow it is indicated by the Q. And in between your this output and input, our actuator element is there. Okay, you will get that output in terms of force and velocity. Okay, so this is the function of your actuator. Okay, now I request you all, please write down the definition of actuator. Okay, within 1 minute write down the definition. Once again I will repeat. Okay, in general, this actuator, it is a device establishing a energy flow between your input port and your output port. Okay, and power exchange happening between your input port and output port, that will be completely defined by the two consecutive variables. Okay, and that variables is named by the efforts. Okay, and here efforts means what? Your force, torque, voltage, and flow means what? Velocity, angular rate, current, etc. Okay, and some input power will be dissipated in into that heat. Okay, into heat, that power will be dissipated in terms of the heat. Okay, and that heat means your undesirable losses. Okay, so for your actuator, input means your that flow and pressure. Okay, and output of the actuator will be your force and variable. Okay, and while conversion of input to output, some amount of heat will be dissipated. Okay, and that will be undesirable loss. Okay, and to represent that actuator input output, that schematic diagram I have shown. Okay, so that actuator will convert the one form of energy, that means your hydraulic energy, that is your input. Okay, that energy or that input is hydraulic energy, you will get at the input port. Okay, and that will convert into the another form of energy. That form of energy means your mechanical energy. Okay, so the input energy maybe to your electric energy or fluid energy or heat energy. But here, in case of actuator, you have to consider as a hydraulic energy, okay, whatever it may be, that electric energy, fluid energy, or heat energy. But your output of the actuator is always a mechanical energy, okay, and that is used to perform the useful work, okay, getting it. And you will see the input port is there, okay. In this diagram I have shown input port is there, output port is there, okay, to the this your actuator, and pressure P and a flow rate that Q, okay, are the input here, getting it. And the pressure P will be decide your actual force, okay. Pressure P will decide your force, and similarly your flow will decide the velocity in case of the your linear actuator, in case of your linear actuator. And in case of rotary actuator, your pressure will decide the torque, your pressure will decide your torque, and flow will decide your the angular motion, getting it, in case of the rotary actuator. Then here what are the undesirable losses are there now during your conversion process from one to another? That undesirable losses means your heat dissipation, okay, getting it. Now we will see some of the important requirements in general actuator, okay. Some of the main requirements for general actuators are here I have mentioned, irrespective of the food power actuator alone, okay. So you will see we require the large travel, high precision is required, then faster switching, either extensive or retraction, or clockwise rotation or anti-clockwise rotation. That faster switching is very important, okay. Then you should that low power consumption. These are the some of the main requirements uh, in general which are required for the actuators, okay. Large travel, then high precision, fast switching is required, low power consumption, uh, then power free force sustainability. For micro actuator, two requirements are added, and that list means the micro structurability and integratability, okay. So mainly these two micro actually the why I include that micro actuator, because in that micro actuators are very essential nowadays to save the energy and also the size of the your that part, okay. And that micro actuator, it is category also we are getting the that some of the fluid power actuators also, okay. Here I want to mention that micro actuators, okay, main classes of the micro actuators, okay. It includes the electrostatic actuator, which is uses electrostatic force for the actuation purpose. The electromagnetic actuators are there, which are used in electromagnetic which uses the electromagnetic force for the actuation. Then piezoelectric actuators are there, okay, which are which uses the piezoelectric effect used for the actuation. Then fluid actuator, it uses the liquid, gases, and plasmas for actuation purpose. Then thermal actuators are there, which uses a heat energy for the actuation. These are the micro actuators, okay, on which many researchers are doing the research, okay. From that you can pick up the one point and you can start your research work also, okay. Piezoelectric actuators or the fluid actuators also, okay. This is just for your information purpose I have mentioned, okay. Now there are macro actuators are also there, okay. Macro actuator are playing a major role or the important role in the main uh, our supplication or the application purpose. Now our concentration should be mainly on the actual, as per this looking to the our syllabus, our concentration mainly on the your macro actuators, okay, not in micro actuators, okay. Like what I am discussing today, that is a uh, hydraulic actuator, okay. So we should focus on the hydraulic actuators, Okay, so in that I have told that, okay, if the actuators are producing the linear motion, that linear actuator, it is also called the hydraulic cylinder. And if actuators produces the hydraulic actuators produces a rotary motion, then that time it is called the hydraulic motors. Okay, so the main two category of the hydraulic actuators are the hydraulic motors and hydraulic cylinders. Okay, are the main category. Okay, that we have to we need to concern about that only. Okay, so the fluid power actuators. Okay, as we know, friend, already that pumps and the compressor perform the function of the adding the energy. Okay, mechanical energy into the fluid energy. They are adding the energy to the your fluid or your air. Okay, pump or compressor, they perform the function of adding the energy. They perform the function of adding the energy to the your hydraulic fluid or air. Okay, while it is opposite now, while actuator, okay, they just do the function opposite to your uh, pump. Okay, what they will do, actuators, they will extract the energy from the your fluid, and that energy it is used to do the useful work. Okay, that means hydraulic energy is converted to the mechanical energy. Okay, and if we will go for the more specifically, then the pump or compressor, it converts the mechanical energy into the mechanical energy received from the electric motor, that converts into the fluid energy, while actuator converts the fluid energy which is received from the pump or a compressor into the mechanical energy. For what purpose they are converting? To perform the useful task or the work. Okay, see, in whole fluid power, okay, okay, fluid power, in whole fluid power, we are converting the mechanical energy into the fluid energy. Okay, and fluid energy back into the mechanical energy to do the useful work. That is called the fluid power system. Mechanical energy into the fluid energy, then fluid energy into the mechanical energy to do the some useful work with the help of actuator. Okay, and here I'm showing you a simple block diagram. You can see simple block diagram. This is a simple block diagram. Okay, here I'm showing the simple block diagram. Okay, and you will see the hydraulic pumps and pneumatic compressor. Here, this is a hydraulic pump, this is a pneumatic compressor. Getting it? Okay, they will run through the both your hydraulic pump as well as your pneumatic compressor. Both will run through the electrical motor. Okay, that means they will receive the energy from the electrical motor. They will receive both to that energy to run these pumps. Okay, pump and compressor. Okay, we require the torque and angular velocity, which will convert. We are getting that energy we are going to convert into the fluid energy. Okay, please remember, pump are or whether compressor that convert your energy electrical that take the electric energy. That means by taking the electric energy they are rotating. Okay, that means the mechanical energy, and the mechanical energy is going to convert into hydraulic energy. They are adding energy. Okay, and by creating some pressure to the that whether that your pumper or what are the compressor are there, no, so they create the resistance to the flow. That resistance to flow will create the fluid energy. Resistance to the fluid flow will create the fluid energy. Okay, meaning it is a pressure, and this will come from the actuator. Getting it? See, fluid energy will get from the hydraulic pump as well as fluid means what? You can consider as a liquid as well as a gas, that is air. Okay, and you will get the pressurized gas, sorry, pressurized liquid and pressurized gas. Okay, if you take example of hydraulic pump, then fluid energy you will get the okay then pressure liquid will get, then that fluid energy you can give to your hydraulic actuator and you will get the mechanical energy. Okay, that means your torque or your angular velocity. Okay, that means they will convert the mechanical energy into the your pump and your compressor. Okay, both. Okay, they will convert the mechanical energy into the fluid energy through the your pump or the compressor. Then this fluid energy, either compressed energy or compressed gas, is an input to your hydraulic actuator or the pneumatic actuator, which they will further convert into the mechanical energy. Okay, and that mechanical energy is used to perform the some useful uh, work. Getting it? So this is a schematic diagram of the our system. So the at output no will get as a torque. We are getting the torque or a angular velocity. Okay, torque in case of linear actuator, at output you will get the torque, and in case of the motor you will get the angular velocity. Okay, I'm sure I'm showing here that motor. Again, if it is cylinder, that actuator will be the linear cylinder or hydraulic cylinder. That time you will get you are getting the force and the velocity. That means the torque. Okay, please remember, friends, this terms. Okay, hydraulic motors or the cylinder. See, here I have shown that hydraulic cylinder or pneumatic cylinder, they are producing the linear motion. Okay, that means at output you will get the force and the velocity, and the actuator, if it is producing the rotary motion, that means your hydraulic motor or the pneumatic or air motor, at output you will get the torque and your linear speed. And if limited rotary motion or the oscillation motion, okay, that is used to produce a reciprocating motion. Getting it? And here I have shown the cylinder. See, these are the cylinders. That is the hydraulic cylinders. Here motors. Okay, that means the rotary. It may be hydraulic motor or the air motor. And limited rotary motion means what? These are the oscillation motors. Getting it? These are the types. What are the generated power are there? No, that can be transmitted. What are the generated power? Okay, at the output of the actuator, are there? No, that generated power can be transmitted to the either your hydraulic cylinder or a pneumatic cylinder. Okay, to produce a linear motion. Okay, and here also I have told you that force and velocity. Forces are decided by the your input pressure, and velocity is decided by the your input flow rate. Okay, similarly hydraulic motor and the pneumatic motor are the here, that pneumatic motor means the air motor, that is used to produce a rotary motion. Okay, and here in case of that, torque and torque, it is decided by the pressure energy of the fluid. Okay, and your speed or angular speed. Okay, whatever it is, that is the parameter uh, that will be decided by the flow rate. Okay, and then one more category I told, that oscillation motion. These are actually types of the fluid power actuators. Okay, getting it? Now I request you all, please draw this schematic diagram. Okay, and then we'll go for then you need to draw this, sorry, you need to write this classification also. Okay, please, whatever I have mentioned, no, that pump or compressor convert the mechanical energy into fluid energy and actuator convert the fluid energy into the mechanical energy. Please write down that statement also, then draw that schematic diagram. Okay, and then classification. Okay, I will give the 5 minutes to write that. This is very important. Take 5 minutes to write this. Okay, be fast. Please write down the definition of, okay, pump oblique compressors convert the mechanical energy into the fluid energy, while actuators convert the fluid energy into the mechanical energy to perform useful work. That is very important. Okay, and schematic diagram I have shown. If your fluid is a liquid, then you have to take into the account of that hydraulic pump. If your input is air, then pneumatic compressor. Hurry up, be fast, be fast. Whether whatever I am explaining, I am telling that whether it is understood to you all, are you getting or not? Understood or not? Whatever I have told, I have explained, whether that is understood or not. Hurry up, please write down. Over. Now please write on this. Okay, hydraulic cylinder, hydraulic motor. Once again, I am repeating, whatever the generated power by that actuator, okay, that can be transported to either your hydraulic cylinder or a pneumatic cylinder. Okay, for what purpose? To produce a linear motion. Okay, linear motion, hydraulic actuator. Then remember, its another name is a hydraulic cylinder. Okay, and if it is a pneumatic actuator, then remember the pneumatic cylinder in case of the, if it is produce linear motion. Okay, and please remember, I have told you that force and velocity, please remember, in case of the linear motion or hydraulic cylinder or pneumatic cylinder, please remember, force, it is decided by your input pressure, and your velocity, it is decided by your input flow rate. Okay, in case of hydraulic cylinder and pneumatic cylinder, which produces linear motion. Okay, and similarly, your hydraulic motor or pneumatic or air motor, hydraulic motor. Okay, and another, if it is fluid, medium is fluid, then hydraulic motor. If medium is the gas or air, then air motor or pneumatic motor. Okay, they are producing a if it is that actuator it is used to produce a rotary motion, then that time it is called the hydraulic motor or the and pneumatic motor or the air motor. Okay, and in case of that, torque, it is decided by your pressure energy of the fluid. Okay, it is decided by the your input pressure energy, torque, and your speed, that means the your angular velocity, whatever it is. Okay, for that input, for that your input parameter, or that is your angular velocity, it is decided by the your flow rate. Okay, torque and speed. And the one more category is for the actuator, and that is limited rotary motor. Okay, that is also known as oscillation motors. Okay, and to produce the that reciprocating motion. Okay, you can see the diagram also, this that pictorial view. Okay, I have shown that. Okay, some cylinders. So that cylinders, they are used to get the linear motion. First picture, these are the hydraulic cylinders or the just cylinders. Okay, they are used to get the linear motion. Okay, their velocity and force is the parameter, output parameter. And in motor, okay, second picture, motor, your torque and angular velocity, these are the parameters. That is, angular velocity means the omega is the output. Getting it? And in a linear, okay, and you can see the in a limited rotation motor, rotary motor means what? Your oscillation motor. Okay, there also, for that also you can see the third diagram. I have shown you the rack and pinion. Okay, rack and pinion, this one. Okay, third one. Okay, you will see that rack and pinion. The linear motion of that of this converted rack, it's a that rack is there. Okay, that will get the linear motion of that. It is converted into the rotary motion, or the rotary motion of this, it is converted into the linear motion. It is called the limited rotary rotation motor. Okay, or oscillation motor. Okay, so these are the three category of the actuator. It may be your hydraulic actuator, it may be pneumatic actuator, but the type is same, only medium is changing. Getting? Please write down. Once again, I will repeat. Linear actuators, they generate the motion in a linear. In short, they generate the motion in a straight line. Okay, to perform the work. And rotary actuator means what? They generate the rotary motion, rotary output motion to produce a work. Getting? And that linear actuator, it is also known as a hydraulic cylinder. Okay, and that is a fluid motor. Okay, that generates the linear motion. Okay, in other words, you can tell hydraulic actuator or hydraulic that linear actuator or the hydraulic cylinder. Okay, is a device which convert the fluid power into the linear mechanical force and the motion. Correct. Linear mechanical force and the motion, that is force and the velocity. And hydraulic cylinder are basically used for performing the work such as pushing, pulling. Linear motion is required, no, in various areas. Getting? Now let us go for the next. So if you see in this slide, okay, irrespective of different types of actuators, it may be the linear, rotary, or oscillation actuators. Okay, irrespective of the different types of the actuators, as we know that the motor, cylinder, limited rotation motors. Okay, so it's having the major application. Okay, which includes the different areas. Okay, the areas I have mentioned here. hydraulic jacks. Okay, there also we need hydraulic actuators. Okay, hydraulic jacks, then dumper, then many earth moving and construction equipment. In that also actuators are used. In that earth moving equipment is what? Your excavator, then bulldozer, JCB machines, road loader, and then many agriculture equipments which are used for the harvesting crops. There also the actuators are used in that also. Then automobile hosting is there, aircraft landing gear is there, brakes, flaps is there, spoiler is there, then thrust reverser is there, constant speed propellers is there, and light controllers is there, flight controls are there. Okay, where different types of actuators are used. Okay, then power steering. Okay, that power steering control and the hydraulic brakes in the automobile. There also the actuators are there. Hydraulic shapers is there, crimping machine, planer, then slitting machine is there. Many more applications are there where the actuators are used. Okay, high power industry machines are there. There are also actuators, steel mills, then marine winches and rudders in oceanography is there. Okay, turntable, we have seen that example. Many robotic application in that also actuators are used for opening and closing that grip on, then driving or the joint purpose. These are the major application areas of the actuator. Okay, where actuators are used. Okay, so please write on this also, applications of the actuator. These are the in general application. Okay, these are the not specific to the only hydraulic actuator or linear actuator or the rotary actuator or the that oscillation of actuator. Okay, in all for all actuator, it may be an hydraulic actuator or other. These are the common application. Okay, or these are the common application areas where the actuators are used. Please write on this. This is very important. Okay, now up till now we have seen in today's lecture we have seen the basic about the actuator. Okay, now we are familiar with that actuator also. Okay, we know that, we come to know that actuator is the one of the important element in the power the hydraulic system, where into the mechanical energy, and that mechanical energy is used to perform the useful some work. Getting it? And depending on the motion process at the output of the actuator is having the three categories. If it produces a linear motion, then it is called the hydraulic linear actuator or the hydraulic cylinder. If it is producing the rotary, then rotary motor, hydraulic motor. Getting it? Please write on this application. In the next lecture, we'll see the in detail about the that further part about the that hydraulic linear actuators. Hydraulic actuator means your hydraulic cylinders, and rotary actuators means what? Motor. Okay, hydraulic motor. So in the next lecture, we will start with the hydraulic motor first. Then we'll go for the hydraulic cylinder. Okay, so please write on this application, and simultaneously please write on your roll number in the chat box. Without writing this application, don't leave this meeting. Write down the applications. These are the actuators application. Write down your roll number, then write down this application, and after completion you can leave this meeting. Tomorrow we'll start the hydraulic motors. Okay, hydraulic motor means it is a subcategory of the your actuator. Okay, whether whatever I am explaining, whatever I am telling, whether it is getting or not.
Yes, sir.
Balaji Pise, are you getting or not? Ruturaj Kale, Rohit Kadam, Dongre, Bandgar, Rahul Gaikwad.
Yes.
Getting, no? Please write on the application, then write down your roll number in chat box, and after completion of this write up, you can leave this meeting, no problem. Okay, hurry up. Just I will show the some pictures. Okay. Okay, so these are the actually actuators. Okay, but these actuators are producing linear rotary motion, so it is called hydraulic motors. Getting it? I have shown the some example. External gear motor, that first one is the external gear motor, it is actuator. Vane motor, okay, every type we are going to see. Variable axial piston motor is there, then a jaw roller motor is there, then this is a radial piston. Okay, everything we are going to see for the lecture. Once again, I request you all, if you are written, if you will not write your roll number in chat box, that means you you are absent for this lecture. Okay, because I'm going to take the help of the presenting. Okay, be fast. Okay, 2 minutes more I will give time. If you have completed this, and if you are written your attendance, you can leave this meeting. Thank you. Okay, see you in the next lecture.